Hi guys, I put out a little booklet now to help us start a revision for paper 2. I think I'm going to try and get a video up every day from now till the exam. So I need you to be watching maybe about half an hour of video a day as part of your revision. Okay, this booklet is on Teams. It's not as, I don't think paper 2 will be, it's a little bit more tricky to predict. There's a lot of things that still haven't come up that can come up in paper 2. So we'll just do our best, go through as much as we can, and then try and narrow it in the day before, in our revision the day before. So here's the kind of things I'm going to go through over the next few videos. Let's start with some similar shapes, but starting with, a lower grade, a C grade question, whether we're only dealing with length scale factors. All right. Now, there was a question before this in the booklet, but I realized I put it in the wrong place. So if you think that's not the first question in my booklet, there was a question, but it was on similar area. So I dropped it down into number 17. So here's the first question according to me. By all means, pause and have a little look. So this question says, calculate the height of the larger badge, but it does say somewhere these badges are similar. That's what we're looking for. Okay, so let me get my pen. As best I can. Now I'll get it right. Okay, so what we have got here, nice that we're in a calculator position, but we've got these lengths that are equivalent on the two similar shapes, so allowing us to work out a scale factor, or in particular a length scale factor, which is 3 divided by 2, into your calculator. That's 1.5. Okay, therefore anything in this direction, we're going to multiply the length by 1.5 to get the equivalent length there, or anything in this direction, we're going to divide by 1.5. So it starts by saying, what is the height? So the height is this number, 4.2 times 1.5. Okay, I believe that's 6.3, but use your calculator to check. And then we're going to go to get the length of the pin. We're going to work backwards here. Okay, so 3.9 divided by 1.5. Again, you use a calculator, but I believe that's 2.6. Just double check for me, okay? Again, I think they're going to be relatively easy. Let's see if there's any dodgy ones in here. Otherwise, you just have a go with them, right? 2 similar flasks for measuring liquid. Calculate the height of that flask. Okay. Just a thought on this one, okay? Just at the end of the question, calculate the height. Yeah, calculate the vertical height of the larger flask. Calculate the vertical height of the larger flask, and it gives us the 3 dimensions there that we're given here. So, again, lovely people, right? To a totally different shapes, but it's just all comes down to that one word. You just got to pick out the word similar. Okay, as soon as you see the word similar in a question, it's all about scale factors. So 14 divided by 8. I need my calculator for this one. 14 divided by 8 equals, and again, press that FD button there. So it's 1.75, right? Let's put that in. And then the height of this is 20 times 1.75, which again, I have going out on a limb, is 35. Could link something like this to Pythagoras theorem. Could, if you look there, I could work that out now, because I know I've got this right angle triangle hidden within this shape, where that's 14 and that's 35, and they could say, okay, now work out the length, right? The length of the diagonal side of the cone, and we would do a little square, add square root. But we'll come on to Pythagoras later. Square root, I should say. We'll come on to Pythagoras later. Hopefully, topic 1, though, anything to do with similar shapes. Just be careful of units as well. All right. I've only done those 2 questions there, but just be careful. If something is measured in, one of these was in meters, for example, always remember that a meter is 100 centimeters. So you'd have to convert meters into centimeters if we've got sort of a mixture of units. Okay, calculate the height of the tree. Correct. Again, always read in a calculator paper what they want the answer, round it appropriately. Okay. This is Pythagoras theorem. We've got a right angle here. Effectively, the tree is there, and then that's our right angle there. Okay. Remember, if we're finding the hypotenuse, it's square, add square root. But if we're finding the base or the height, in this case, x is the height of the tree, then it will be square. Yeah, I know that, but I'm doubting myself. So 18 squared equals 324. Subtract those from each other. Okay, what is that? That's 76. And then the square root is 76. And the chances are we're in a calculator paper, so they're not going to say sort of leave your answer as a square root or simplify. In this, we're going to actually do that. Okay, so again, FD to that, so 8.7 to 1 decimal place. And just keep an eye out for Pythagoras will be in there. Always in paper 2s, yeah. So just keep an eye out and make sure we don't mix it up with trigonometry like we could do here. Okay, I know I've only given you in this section calculate x. However, I think it might be worth me working out y as well, the angle. But let's start with x. We can get x with Pythagoras theorem. We have enough information. We have the height. We have the base. We're trying to find the big side, so we can do square. And because we're finding the larger side, we're going to add these. Show though all your workings. Even though you've got a calculator, everything that you're putting in the calculator, write it like that or write it like that, but show what it is you're actually doing. Otherwise, you'll drop marks if you don't get it right, okay? And don't forget the square root at the end. Square, add square root in this case. And I haven't got the foggiest. What that is, the square root of 153. Let's guess it's 12.2. 12.4. Okay. 12.4 to 1 decimal place. It says, look, three significant figures. So if you have a look here, 1, 2, 3. The third significant figure is the first decimal place here. So if I'm rounding to the first decimal place, that's going to be 12.4. So just, Pythagoras could be hidden in there, but just be aware, square, add square root, square, subtract square root. Now, I got rid of the bit here, right, on finding y, because I was going to do it down in trigonometry, right? However, let's do this, okay? Let's find angle y. Because we're finding an angle, this would be trigonometry, right? What sides do I know? That is opposite the angle. That is the hypotenuse, the big side, and then the adjacent is the one we always label last, okay? So Kartoa, right? We want to find the angle. We always cross at SCT, but what sides do we know to allow us to do that? We know O, opposite, and we know A, adjacent. The side that we don't know and we don't care about is that. Well, technically, we do know it now, right? We do know it now, but I think this was, this part came before we would have done that, if that makes sense. So at the time of working out why, we didn't know the hypotenuse, so pretend we didn't, okay? We're going to use TOA, and TOA is TOA, and because we're finding the angle, right, tan, that's what the T stands for, theta, equals the opposite, 3, divided by the adjacent, 12. Therefore, to find theta anytime we're finding an angle, we're going to tan minus 1. That, you could have worked out that 3 over 12 already and put the answer in. I think it's 0.25. I'll put that into there. So watch how I do that. Shift tan to bring up tan minus 1. Then I can use this button if I want to and put 3 down 12. Don't close the button, come over and close the bracket there. So it looks exactly like that there. And to 3 significant figures, that would be 14.0 or just 14, okay? Just 14 degrees. So that's using trigonometry to find an angle and using Pythagoras to find a side. You're going to get both trigonometry and Pythag in any paper 2. And here we go, another chance that they've taken to mix similar shapes in, okay? So if we have a look at this triangle again, 12 and 3, this one is saying that there is a similar, right, so similar to, let's draw this one here to help me. So it was, again, pause and have a go if you want to. Anytime, pause, that, and these are similar. So I need my scale factor by dividing those. Yeah, so my scale factor, I've seen that word similar, is 1.5 if you do that. And then to work out the horizontal length of the door wedge, this one here, it would be 12 times 1.5, which is 18 centimeters. I hope similar shapes, Pythag and trig, are quite routine for you guys. Okay, similar shapes, Pythag, trig, they need to be. Okay, chaps, Pythag again, right? Pythag again. The mass, it's basically, right, we're trying to find the mass of the wire, and it's 0.489 grams per centimeter. So I need to work out how much wire I've got. So there are two things missing. I don't know how much wire is there, and I don't know how much wire is there, right? Well, to find that one, we can square, right? Subtract and square root, right? Once we know this one, to get this one, we will square this, add them, and square root. Okay? Once we know all of the sides, we can add them all up, right? So the 4, add the 5, add the whatever that one was, add the 1.6, add the whatever the other one was, add them all up, right, in centimeters. And then we're told that the mass is 0.4. Basically, this is the density. This is the density. So you've been given the density here. So this is using density, mass, volume. Again, another little formula that could very well come up. And to work at the mass, we need the density, 0.489 times, okay, I understand this isn't volume that we're using here, okay, so, but it's the same idea, right? Because this isn't a mass per centimeter cubed, it's a mass per centimeter. I'm basically swapping volume for length. And the mass is the density here times the length, right? Whatever that is, if that sort of makes sense, okay? I want to have a look at some angles in parallel lines in this video as well. Let me just check how long I've got left. You know that I do things, you can see how this works now. 2 minutes left, and then there'll be a jump. So let's do a couple of these, right? You can read all the gumph there, right? But really, if we get some parallel lines, chaps, let's put in everything we know. If this is 65, this is 65. Take the 65 away from 180, you get 115. This is 115, and this is 115, okay? This group here that we've worked out is the same as the group down here. So down here, you've got 115 and 65, but, oh, look. What they've done here is this 115 that's also here, that's opposite here, they've split it into two parts, 42 and Z. So actually, to get Z, I need to take the 42 away from the 115, which is 73 degrees. Okay, and then the other angle I'm giving you is 70, so this is 70. Take that away from 180, we get 110, 110, and this group here is the same as this group here. So this is in the 110 position, so X is 110. And obviously I'd worked out Y here, okay? So just, yeah, easy enough parallel lines, aren't they? You know, a little awkward one there, that bottom of that Z one. You know, there's a lot happening here. Let's just try and work out what the parallel lines are here to end, okay? Actually, we'll take a little break. We'll come back in 10 seconds. My apologies if there was a bit of a jump there. There will be sometimes because, like I said, I do these in 15 minutes sort of breaks. But look, again, it's a lot happening here. A lot happening. I'm trying to work out, actually. But can I just scroll up a minute? Okay, right. Here's the thing. These two are parallel. So any group cut in these two, they will be the same group, right? But also, this one and this one are parallel. So any group cut in those two will be the same. But the other line, this one here and this one here, are not parallel. So bit of a problem. Okay. So now, if we start by coming down to A, let's start with A. Now, I have got this line here cut in the two parallel lines, this one and this one. So these two groups are going to be the same. So if that's 125, that's 125. Take it away from 180, you get 55. And if that's 55, that's 55. And you can see that A is in the position of a 55. So let's start with that one. Fab. It would be easy to fall into the trap of thinking that the 130 is linked, but it's not, because this is, if we think that 130 is part of that dodgy line. So at the moment, I just want to leave that alone. I have no idea how we're even going to get to that, but hopefully we can find a way, okay? Whether that 130 helps us somewhere. Oh, I suppose it does. No, maybe not. No, hang on. Maybe it's just there as a red herring. Let's keep going. Okay. This line here, so awkward, these, aren't they? This is a really awkward one. Cuts through these two parallel lines. We need to ignore this line, right? And if we've got 76 there, then we've got 76 there. And we'd also have 76 there. And we'd have 76 there, right? So D, I'm doing D next, is equal to 180 take away 76, which is 104, right? I am just going to tidy this up a minute because I just think there's too much going on here, right? Let's get back maybe to a different color. Hopefully that makes sense. What idea is that, right? Okay. Now, again, chaps, now we can look at this, which runs through the two parallel lines here. B is in the 76 position. C is in the same position as D. So C and D are the same in this case. So C is also 104 because of the same reason as D, but B is in the 76 position. Now, how nasty is that? That we didn't use, and that we didn't use because they were part of lines that just, like this one was part of a line that just wasn't one of the parallel lines. It didn't cut any parallel lines, so it just didn't help us at all. And the same with the 130. So that was just one to be super careful of, and just take your time with, really, okay? And use your common sense a little bit, right? Let's move on to some circles, area and perimeter of circles. Look, this is just a reminder in paper 2 that we must get something like a circle or a semicircle or something. Just a reminder that the area of a circle is pi times the radius squared, okay? And the circumference of a circle, so the distance around the edge of a circle, is pi times the diameter. Cherry pie is delicious, apple pies are too. Cherry pie is delicious, apple pies are too. Work at the area of this circle. I'm not doing it, right? Pi times, what mistake have I made? What mistake have I made? Okay. It's pi times the radius. I need to half that. So for the area, I wouldn't be using 9.2. I would be using half of the diameter, but making sure I square it in my calculation and putting that in my calculator to answer in centimeters squared in that case. Okay, rushing through some of these. They're easy. Right, calculate the area, give your answer to 2 decimal places. I'm not going to say anything. And that pi times, again, just use pi r squared, do it. Okay. Or don't. If they're easy, leave them. Right. Work at the area of the semicircle. Okay. It's kind of like the area of a sector, isn't it? It's just the sector is half the circle. Right. So the easiest way is pi times the radius squared, but half it. It's only half. So I tell you what I will do in this one, if you want to pause and do it. That would be the area of the semicircle. Can you also do for me the perimeter? If you want to pause, I will go with the perimeter of the semicircle. And if you didn't pause and you want me to do it, then we would need to know how far it is. Perimeter is how far it is for a little person to walk around the shape. So the little person would have to walk halfway around the circle and then back along. So he would walk the circumference of the circle, pi times d. In this case, d is 12, so pi times 12, but only half of it. Okay, plus that would bring him to here. halfway around the circle, but then he'd have to walk back to where he started, which is an extra 12 along the diameter of the circle. So you could try that one as well and put some numbers in. Again, I don't want to waste too much time using the calculator when you can do that bit. Okay, square has side length 16. Find the area of the logo that is white. Okay, chaps, if the length of the square is 16, then each diameter must be 8. Therefore, each radius must be 4. So each circle would have an area of pi times 4 squared. Take your answer, which is 1 circle, and times it by 4. That will give you the area of the 4 circles. Starting with 1 circle, times it by 4. We could also get the area of the square. Because it is a square, both sides would be 16, so that would be 16 times 16. And take the circles, take this answer away from this answer to just leave yourself the white bits. Okay? Easy enough, isn't it? Have I gone too fast there? Hang on a second. Lost my mouse. Such a high quality production, this, isn't it? Okay. Just cover as many things we can in today's half an hour, okay? Estimated mean from a frequency table. Okay. I'm going to add into that as well. We'll talk about the modal group and the group containing the median. We'll talk about all three, just in case. Again, really common question. There's enough in here, just repeats. Okay, you should read this, you shouldn't just write, but I'm being told there's 30 days in April. That might be useful, might not. Oh, okay, because they've ripped off. Okay, so first things first, I need to work out how many days at a temperature between 23 and 24. If I add my 4, and I add on the 8, and I add on the other 8, I'm up to 20. Therefore, there must be 10 in this ripped off bit, because then they add up to 30, which is the number of days in April. So I can see now why they've told you it's 30 days. An estimate for the mean, okay, would be you're going to do the midpoint times the frequency. Okay, so the first 4 days on average, let's say, were 20.5 times 4. Okay, that's 82. Correct me if I'm wrong, okay? 21, or in your work, it's correct me if I make mistakes without using my calculator. 21.5 times 8, 22.5 times 8, and 23.5 times 10. That one I can do is 235. Okay, let me just grab my calculator for these two. So let's go to 21.5 times 8 equals 172. Back to calculator. And 22.5 times 8 equals, with pointing out at this point, look at the top of the calculator. The only thing that's got to be there, I know it says math, don't worry about that one, is D, degrees, right? If you want to change, that should say D. If yours says R or G or something else, okay, go shift, mode, and it's number 3, press 3. Okay, so just do that for me. Maybe before we start the exam, shift mode 3 and get it into degree mode. Okay, that's 180. We then need to add these all up, get the total temperatures for all 30 days. So 82, add 172, and this is boring just watching me hit a calculator, isn't it? Add 235 equals 669. Okay, don't make the mistake then of dividing that by 4 because you've added up 4 numbers. Divide it by this, the total days, the total people, the total dogs, the total whatever it is. That's what you're dividing by. We have not added up 4 numbers, we have added up 30 numbers here. So we'll divide that by 30 and 22.3, which kind of makes sense because it's kind of 22.3 is sort of in the middle here somewhere, isn't it? 22.3. So that kind of makes sense. Right. Okay. We also mentioned the modal group. Even though the estimate of the mean is the big marker, there's 5 marks here, look. Right. The modal group, where am I? Is the group that has the most highest frequency, the most people, the most days. And in this case, the group that has the biggest amount in it is the group 23 to 24. So I'm just copying, okay? And then finally, the group containing the median, right? This is a bit harder. So there were 30 days. The median day is the 15th. So what this question is asking you is, which group contains the 15th day? Which group has got the middle day in it? So if we start with the 4 and add 8, we're up to 12. So there are 12 days in there in total. When we add the next 8 on, we go from 12 up to 20. So that group contains the 15th person. So the middle person, in this case, the 15th person, the 15th day in this case, is in the group 22. Having said that, chaps, these are little 1 markers. Estimate the mean is the big marker here, right? Same again, chaps. Yeah. Estimate the mean. Right, midpoint times frequency. Add them all up and divide by however many there is here. So 15, 24, 31 in that case. So that's what you would divide your final answer by. Okay, so midpoint times frequency, add them all up and divide by how many there are. Just be careful, right? The groups here we've used so far are quite regular, 1,000 to 2,000, 2,000 to 3,000, 3,000, right? Just look at each group separately, because sometimes they throw a spanner in there and there's like different group widths. So the first might be like 1,000 to 2,000, then it might go like 2,000 to 8,000 or something, right? So just be careful. Take each group separately when you're working out your midpoints. Yeah, we might try this because it's unusual looking groups, aren't they? So which group contains the median? Well, I need to know how many there are. So 3, 10, 22, 40. So basically, which group has got the 20th person in it? Again, 3 add 7 is 10, 10 add 12 is 22. So person number 20 is in the group 11 to 15. In terms of estimating the mean, chaps, again, it's the midpoint times the frequency. If you're not sure of the midpoint, add up the numbers at the ends of each group and half it. So 1 add 5 is 6, half of 6 is 3, times it by the frequency. 6 add 10 is 8 is 16, half it is 8, times it by the frequency, and so on. Okay? Okay, and don't forget then to add those together, and yeah. Same here. Right? Same here. Find the midpoint. Chaps, probably another bit of a jump there, actually. Right. Honest. Doubtful. In higher tier, paper 2, I think I've seen it once in the last few years, right? So it's in here. Look, I can run one really, really quickly, okay? But here's the idea, right? Some like the kind of this, right? However, look at your tax rates. Up to 4,000 is free, okay? 4,000 up to 10,000 is taxed at 15%, and anything above 10,000 is taxed at 22%. However, look at that, okay? So we're talking about this person here who owns much more than 10,000. She owns 30,000 euros. Okay, let's take a little look at how much is in each section of this 30 grand. So half her 30,000 euro earnings, 4,000 of it is in there, being taxed at 0%. From 4 up to 10, so in other words, 6,000 of her euros is in there, being taxed at 15%. Sorry if you know the background, that's my dishwasher. And from 10 up to 30, so 20,000 of her euros is in there, and that's being taxed at 22%. Now, what we will, the reason I'm doing one, even though income tax doesn't come up, is if we are doing percentages in a paper 2, we may be best going times 0%. 6,000 times 15%, 0.15 is doing these. You can do it the non-calculated way of going, what's 10%, what's 1%, what's 5, doing it like that. But basically, we can do everything as decimals. And if we total those up, we will get, obviously that's 0, okay? 15% of that, I believe, is 900. Just sorry if it's not. 22% of that would be 2,000, 4,000, 4,400 maybe, right? Added together, you get 5,300 euros is her tax, okay? The part A here actually was weird. It said, show that Simone should have paid $900 tax at the basic rate. Well, that's what I've done there, right? This is the basic rate in here. Says so here, this is the basic rate, right? And in there's 6,000 euros being taxed at 15%. So all I would have written in here to show that is just the second part of the workings, maybe just that bit. There's 6,000 being taxed at 15%. The 6,000 in there being taxed at 15% equals 900 euros, done, right? The rest of the bill then would go into part B. It's unusual to separate it out though. Normally it's just one bill, okay? Same there, give it a go, right? Have a go, a couple of them, right? But again, I found 2 there, and one was from a non-calculator, so chances are no. Okay, right, density. We talked earlier, we need to know this formula, yeah? Density, mass, volume, DMV in that order. D at the bottom left, MV, right? We need to look at units and stuff, right? However, there's another type of density, sort of a real-life density, okay? That, I've called this population density, but because it's linked to population data, but it's not. Basically, population density, sorry, I'm getting my words mixed up here, is how many people live per kilometer squared, for example, right? Or how much waste is produced per person, right? So it's calculations, but all the calculations are per how much per something. I know that sounds ridiculous, yeah? So in this case, Gwilym is giving a talk about the amount of food that was wasted in 2019. He has found some details of food waste in 2019. So China wasted this much food with this population. So I can work out how many kilograms have been wasted per person, right? So any type of density is the total of something divided by the total population. In this case, sorry, that's gone off the screen, isn't it? Right? So, yeah. Okay, let's keep going. I don't think I've done a great job of explaining that, but let's have a look. The population data seems to be given correct to a certain number of significant figures. To how many significant figures does it seem to have been given? Well, have a look here, chaps. How many figures have they given before in each population number before they've started putting zeros? Looks like there's 3 significant figures there, right? Okay, use the data from the table to complete the following statements. On average, a person in France produced blah, blah, blah kilograms of food waste. Okay, so in other words, how much food waste per person? So in France, we're going to divide this, the total, by the number of people to get the waste per person. Let's drag this over and see if we, yeah, it's just about out of the way, isn't it? Right, so let's go, start this thing again. We'll go 5, 5, 2, 2, 3, 5, 8, 8, 0, 0, 0, divided by, everything's calculated, which is nice, isn't it, in this exam? Oh, 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 something on it, yeah. I think I got enough zeros that way, yeah, equals. Okay, so 84.4. Okay, that'll do. 1 decimal place will be perfect for that, I think. Okay, this was how many times the average in China. So let's do China next. They quite like this. So like, how many times more is it than that? So let's have a look at China next. How much did they waste per person? Well, they wasted 90 21,646,213,000 of waste, but they got a lot more people. They've got 1,440,000. 123 million. Okay, equals. All right. That's strange, isn't it? This was something times the average amount of food waste per person in China. Okay, so effectively we got here about 63. Sorry, I'm putting it up there. 0.6. 63. So for China, we got 63.6 per person, and for France, which we've already worked out, we've got 84.4. Now, to work out how many times something is bigger than the other, it's like a length scale factor. How many times bigger is something? Well, we've got to divide those, okay, to know how many times bigger. So if I divide those, all right, 84.4 divided by 63, let's bring it over here. 84.4 divided by 63.6. Bear in mind, we've rounded these answers as well. So as long as we, yeah, look, you can get away with something there, right? Maybe one decimal place there, about 1.3 times as big. Looks weird because it's all rounded answers, isn't it? So it's not, but have conviction in what you're doing, all right? Is that? Oh, okay. The area of the United Kingdom is that. Use this information and information from the table on the previous page to answer the following questions. What's the population density? Okay, but look, people, so I need again to know how many people and divide it by this area to get how many people live, right? So let's have a look what the number of people in United Kingdom was. It's there, yeah, 67.6 million. I'm just all over the place here, aren't I? So it was, there are 67.6 million people, right, living in 242,500 kilometers squared. So if I divide those, I will get how many people per kilometer squared. That's what population density is. How many people per kilometer squared. So for population density, it's the population divided by. Okay, so just be prepared to do calculations for that. Put the answer in there. What was the average food waste per kilometer squared? Lovely. Okay. Food waste per kilometer squared. Okay, well, we've got to do the same there. One thing you need to pick up here, I mean, we've done calculations like this already, okay? Something to pick up in this bit of video again, right, is this idea here. You may need to do this conversion, okay? We need to know that 1 ton is 1,000 kilograms. So a gram, 1,000 of those makes a kilogram, and 1,000 of those makes a ton. So because they want it in per kilometer squared. Oh, see, this is slightly different again. So now this is food waste per kilometer squared. So here we want the food waste divided by the area, but we want the food waste in tons. But they've given us the food waste in kilograms, I believe. The United Kingdom. Yeah. So basically, we'd have to divide this by 1,000, get rid of those 3 zeros. So that there is the food waste in tons without those 3 zeros on the end, divided by the area of the United Kingdom, which is given to me in that question. So we are jumping back and forth, but this is all an understanding of what per means. This per this, food waste per kilometer squared, people per kilometer squared, food waste per person, right? And dividing the right numbers. Oof, a lot going on there. Okay. Thank goodness this is just population density here, though. Thank goodness. Okay. So all we're doing here for population density is people per kilometre squared. So divide that by that for all of these. Okay, you can have a go at these. So which of the 5 countries was closest to 100 people? Well, just divide them and we'll see which is closest to 100. Which of these are the greatest population density? Divide them. Tell me which one's got the biggest. Which of these had a population density approximately 4 times that of Canada? Right, so work out Canada. Oops, work out what Canada's is. Work out what Canada's is. Times it by 4 and see which one's closest to that. Right, so that's population density, and other types of densities as well, like food waste density and various things like that. Right, Trig. Thank goodness we're here. Okay. Calculate the height of the, what's it say? Calculate the height of the bottom of the kite above the ground. Will do. Okay. We need the height of the bottom of the kite above the ground. But if we start with this, we just know that then we need to add this 80 centimeters on. So let's have a little look at the triangle. In this triangle, this is the opposite. This is the hypotenuse. And this is the adjacent. Okay. In terms of TOA, I know the angle this time. I know an angle is 63. I know the hypotenuse. I know that that is 8. And the side I'm interested in is that one. So the side I want to know is the opposite. And then the adjacent down here, I don't know it and I don't care what it is. So what I'm using is so. Okay. And I'm trying to find the height of the opposite. So to do the opposite, I need the sine of the angle, which in this case I know, times the height, times the hypotenuse. I'm having a really good time. Let's put that into here. Sine, put the angle in there, close the bracket. If you forget to close that bracket, right? If you leave it like that, that'll be, I'll put a times, that'll be wrong. Close the bracket, then times 8 equals 7.1 meters. Okay, it's another units problem, isn't it? Right. Well, I need the height of the bottom of the kite, right? So that's 7.1 meters and that's 80 centimeters. Well, pointless adding those for a minute. But 7.1 meters is 7 times that by 100 centimeters in a meter. Then add the 80. So in total, that height is 790 centimeters. Or you may have done vice versa and changed that into meters, 0.8, and added it on, in which case you would have got 7.9 meters. I'd take either, right? Take either of those. It's very similar, isn't it? In fact, similar, really similar. It's the hypotenuse we know, and it's the opposite I want to find out, and there's the angle. So I'm not doing that one again. It's the same. Very, very similar, right? And we've already done one finding an angle, haven't we? Right, so which is why I haven't done it there. Okay, so I look back earlier in the video where I did finding an angle. It was